All right, thank you very much. I'd like to give you a quick overview and update as to what's going on with NASA's Moontrek portal. There have been some changes. So NASA's Moontrek is one of a family of portals in NASA's Solar System Treks project. These are a series of data visualization and analysis portals that are targeted at planetary science, mission planning, and public engagement. These provide views of a growing number of planetary bodies throughout the solar system as seen through the eyes of many instruments aboard many different spacecraft. Our flagship portal is the Moontrek portal. This is the one that we've been at the longest, and this is the one for which we have the most data. The heart of the Moontrek portal is thousands of layers of georeferenced co-registered data products from many different missions, instruments, and spacecraft. They provide the ability to view a given area on the surface of the moon in many different ways. As you load these different views, you create a stack. And within your stack, any of the images or data products you've selected, you can do a variety of things, including download that data product. You can reorder the items in your stack, and you can even adjust transparency to blend different data products together. So here, for example, we see a blend of laser altimetry and gravimetry. The views that are provided are diverse. You can have equal rectangular projections. You can have polar projections, so flat maps such as this, or you can switch into an interactive 3D view and go cruising across the surface of the moon, either roving or flying. It's a lot of fun. So integrated with all these views of data products are a wide variety of analysis tools. Basic analysis tools are available to anyone who visits the site. Again, this is all web-based, all browser-based. You don't install anything. You just point your browser to trek.nasa.gov. Basic tools allow you to do simple things such as measuring distance or obtaining elevation profiles as simply as drawing a transect or a traverse path. You can draw bounding boxes to generate STL or OBJ files for 3D printing. Another fun aspect, particularly useful in public engagement, is the generation of VR experiences, custom VR experiences. Simply draw a path across the surface of the moon. It'll come back to you with a QR code. Scan that QR code into your smartphone, put your smartphone in a pair of cheap $5 Google compatible goggles, and whatever path you drew, you will fly in virtual reality. We also have the ability for researchers to get account level access and thereby get more computationally intensive and more advanced tools. These include such things as AI and ML based crater detection. This finds individual craters on NAC strips, produces GeoTIFF hazard heat map, GeoTIFF of identifying all the craters that have been found, and a text file detailing those craters. Similarly, we have rock detection, AI and ML based, and working with Valentin Bickel, we have been able to extend this capability now to include rock fall detection. We also have, of course, slope analysis. That'll be necessary for landing site and traverse characterization. Ray traced surface lighting, including irradiance plots of watts per square meter. And we have a number of new tools that I'd like to highlight very briefly here. These include a data plotter, and this is in many ways similar to the elevation profile, but now instead of plotting elevation for whatever path you draw, you will see a plot of a wide variety, a growing variety of raster data. So that might include mineralogy, thermal data, gravimetry, et cetera. We have a new NAC search feature. So for any path or polygon that you draw, you can find what NAC strips are available, and you can refine your search by lighting and geometry. For engagement, we have the new Country Mover tool that allows you to drag an outline of any state, any US state or any country across the surface of the moon for size comparison. We have the ability to annotate maps that you generate. And we have our new line of sight tool. This is especially useful in communications planning. It takes local topography into account. So it'll determine whether you have a clear line of sight between any location on the moon and another location on the moon, or a location on the moon and any ground station you select on Earth, or a location on the moon and an orbital relay asset, or between any two spacecraft in orbit around the moon. We have new capabilities, including generalized feature detection. So extending the AI and ML base to train to new other types of features, as well as 3D interactive traverse path visualizations. So you can actually position yourself above a traverse. You can move your camera position up and down, pan left, right, and you can load various data layers as you control your traverse along your designated path. Again, this is one of a number of portals that we include in the Solar System Treks family. We have two new portals that we have recently added. Those are the Venus Trek and Europa Trek portals. In conclusion, I'll remind you that the Moon Trek portal is available to facilitate lunar and planetary science and mission planning. And it will enable the dissemination of your data, enable the dissemination of your data products. Did I lose that? Looks like I lost it. But it will enable the dissemination of your data products and provide them with increased value through the context of a vast store of other data products. It's an excellent means to advance your analysis algorithms into online tools. So if you have an algorithm that you would like to see turned into an online tool, example again, Valentin Bickel working with rockfall detection, Bill Farrell working with electrostatic surface potential, and Simone Dall'Agnello with lunar laser retroreflector geometry studies. We can work with you on that and turn your algorithms into online tools. And we can enhance public engagement efforts supporting missions and research programs. Thank you very much.